Okay, I'm going to kind of show you guys how to graph piecewise functions and then how to evaluate them. So first off, a piecewise function is basically a function that, depending on where you are within the domain, you might be following a different equation. So I kind of think of it also as different functions pieced together, since it's piecewise, to make one larger function. So on this one, you are going to graph y equals 3, like that equation, for all x's that are less than or equal to negative 3. So negative 3, and I'm doing my best, I'm going to be on my tablet again, so try to make your lines as precise as possible. So I have this line here that's y equals 3. I only need it for all of the x's that are less than or equal to negative 3. So where my x is negative 3, I'm going to go ahead and put like a closed circle right there, so I'm very clearly using that. And then I'm doing every x to the left of that follows that equation. For the next chunk, or the next piece of my function, I'm following y equals the absolute value of x. And I'm doing that between negative 3 and 4 for my x's. See, that says between, that's negative 3 and 4, and the or equal to is inclusive, so I need to make sure I have closed circles on both ends. So you can see my V. Again, sorry, I'm using my fingertip, not even my stylus, because it's not working. And I'm finishing with a closed circle. So that middle chunk is the absolute value of x. Then for my last piece, I'm just graphing the line y equals 4, and that's for all x's greater than or equal to 4. So I would start with an open circle, except for that open circle is actually right on top of a circle that is already closed, like I've already identified that point works. So it stays closed, it does not open back up, and everything to the right. So I don't have any holes or anything on this one. And this, all three of those together, makes this function f of x. On this next one, I just have two functions I'm graphing. The first one is 2x plus 1, so that should be a line where you're starting at 1, and you have a slope of up 2 over 1, going in both directions. Please use a ruler when you are doing this on your paper. Now, I only need it, you can see I put all my dots in all the way across, but I only need it for the x's less than 0. So I'm going to start with that open circle where x was 0, which happens to be at 1, and everything to the left of that I can follow. Again, use a ruler, follow your points precisely, so that you can get a nice straight line in there. For the next part of my function, I'm following the line 2x minus 1. So that would be starting at a negative 1, up to over 1, up to over 1, up to over 1, and so forth. And I'm doing that for all x's greater than or equal to 0. So at 0, I'm going to have a closed circle, and then I can follow my line to the right. Again, please use a ruler as you are doing these, especially for these lines, so that they are nice and precise. But that is my function. Now on this one, it is not continuous. You can see as you come across, like I'm following my red graph across from the left, and then all of a sudden it jumps down to the blue graph. So because it jumps down, that's called jump discontinuity. And that happens at x equals 0. So while you are graphing these, go ahead and note whether they are continuous or not. Now, you are going to complete the next 5 graphs on this piece of paper on your own. My keys will be updated on Google Classroom probably on Thursday. That way everybody's had a chance to get to this. So you can check your answers. If you have questions, be sure to let me know. The next page in your packet has just some practice evaluating piecewise functions. So I just want to do 2 examples real quick. It is a 2-sided page. I'm doing an example from the front because the back kind of matches what we've already done. So on the first one, I'm doing f of 0. So first thing I need to do is figure out which one of these criteria that falls into. So f is less than or equal to 2, so it will fall into the criteria of the first function. 0 is less than or equal to 2. So I'm plugging in a 0 into that first equation. And then 0 squared is 0, times the negative 2 is 0, minus 1 is negative 1. So my answer is negative 1. For f of 5, that falls into the category of being greater than 2. So I want to use that function. 4/5 times 5 minus 4. When I do that, 4/5 times 5 would just be 4. Minus 4 is 0. That's all you're doing for each of these, is you're trying to decide which one it lands in, which domain you follow, and then do that function. The other type that I'm going to have you evaluating is when instead of giving you the equation, I give you the graph, but you're still just following what it says. So f of negative 1, well, negative 1 is right there, and the value of that graph, oh, that's at 0, so that one's 0. F of 2, well, 2 is right there, and when I look at where my graph is for 2, it's up here at 1. F of 1, I'm looking on that graph, and I have a closed circle and an open circle. The closed circle is the one that's the point. The open circle means it's everything up to that, but not including that value. So that would be right here at 1, and you're doing that. Again, you're completing the rest of this page, front and back, and then submitting your pictures on Google Classroom.